Hello, welcome to your first AP Calc review. Today we're going to be reviewing limits. I'm going to try to keep all reviews underneath 15 minutes. And feel free to pause the review anytime, do some of the example problems on yourself before I answer them, or play me at double time. Anything that helps you is beneficial. Most of these reviews are things you've seen before, thus the word review. So most of them are just going to be example problems, and we're going to go over the example problems and just kind of remind ourselves why the answers are what they are, how to find the answers, and then end it as quick as you can so you guys can get started to reminding yourselves and trying some example problems on the worksheets. Today we're reviewing finding limits. We're going to find limits graphically. We're going to find limits with substitution. We're going to find limits by factoring or simplifying, and we're also going to find limits by analyzing. Very first one up is finding limits graphically. I'll have the title of each one here so that if you only want one of those four, you can skip ahead in the slide to get to the one you want. Here we have a graph and four limits. This very first one up top is asking us to find the limit as x approaches 1 from the left. That little negative symbol there again means finding the limit as x approaches 1 from the left-hand side. So from the left-hand side, here's 1. As I get closer and closer to 1 from the left-hand side, my value gets closer and closer to this point right there, which has a value of 1. So the limit from the left is 1. Next one's asking for the limit as x approaches 1 again, but this time from the right. So again, here's 1, but this time I want to approach from the right side. So from the right side over here, I travel along here, I hit a hole and I jump up there and I jump back down. I get closer and closer and closer to this hole right there, which has a value of 2. So the limit as x approaches 1 from the right is equal to 2. The limit as x approaches 1, if it doesn't have a specific side, like the right side or the left side, like the two above, it means from both sides. Here we're going to have a problem though, because we mentioned from the left side, I get closer and closer to a value of 1. From the right side, I get closer and closer to a value of 2. As you may recall, if the limit from the left and the limit from the right do not agree, the limit as a whole does not exist. So the limit as x approaches 1 of f of x, that limit does not exist. See if I can fit this in here. There we go. Very final one for limits graphically is the limit as x approaches 2 of f of x. Well, 2 is right here. So as I approach this spot here from the right-hand side, I get closer and closer to that hole, which is at 1. From the left-hand side, I get closer and closer to that same hole, which is still at 1. So the limit as x approaches 2 of f of x, that's equal to 1. Some of you guys always note that at 2, exactly right, at 2, my value is actually at 3, but limits, again, don't really care what happens at that value. Limits care about what you're approaching as you get closer and closer to that 2. Moving on, next topic, finding limits with substitution, probably one of the fastest and easiest ways. If you've got a continuous function, like 2x plus 1, you can just plug that in and the limit will be the same thing you get as if you had plugged that number in. Plugging a 3 in, I get 2 times 3 plus 1, which is a final value of 7. Substitution works really slick. Here I've got a piecewise function. I can also find these limits with substitution. I gotta be a little bit more careful there because f of x looks like x squared for any values less than or equal to 0. And then it suddenly switches and looks like e to the x for any values greater than 0. This particular problem is asking me to find the limit as x approaches 0 of f of x. So right at that part where the x squared switches to the e to the x. And so I got to look at these from a left-hand side and a right-hand side perspective. To the left of 0 would be any numbers less than 0. So from the left-hand side, I look like x squared, which I could use substitution to just plug a 0 into there. 0 squared is still 0. So the limit from the left is 0. However, from the right-hand side, as x gets closer and closer to 0 from the right, then I'm using e to the x. I can use substitution here as well, plug a 0 in there. I've got e to the 0, and anything to the 0 power is 1. So the limit from the right, that's 1. Which leads me to another problem. The limit from the left and the limit from the right do not agree. We know when that happens, the limit as a whole does not exist. So the answer for this one is the limit does not exist. All right, that was limits with substitution. Finding limits by factoring and or simplifying. This one would be really tempting to try substitution, but if I plugged a 16 in there, I'd have 16 minus 16 on top, which is 0. Divided, oops, didn't mean to show that yet. Hold on. Divided when I put a 16 into there, I've got 4 minus the square root of 16. Square root of 16 is 4, so I've got 4 minus 4, which is also 0. 0 over 0 is a problem. It is not a number. I can't say it's undefined for a limit because maybe I go towards something and I just don't know. So I can't deal with that. I've got to find some way to fix it. One of the ways we can fix it is by factoring. You may recall that a squared minus b squared equals a plus b times a minus b. Hopefully you do. That's a pretty big one you should definitely know. If I look up here, 16 is a perfect square. That's 4 squared. X is also perfect squared. It's square root of x squared. So I can use this handy dandy thing to factor that. I didn't want to write it out with my mouse because I'm really bad at writing with my mouse, so I did that in advance, and here it is. I can factor 16 minus x into 4 plus the square root of x and 4 minus the square root of x using this factoring shortcut that I've learned before. So let's actually do this. Let's say because of this, I can do that. Factoring can make our lives a lot better, of course, because now I've got a 4 minus square root of x on top. I've got a 4 minus square root of x on bottom. Those cancel out with each other. And then I can say, hey, well, the limit as x approaches 16, I can now plug that 16 in. If I do that, I end up with 4 plus the square root of 16, which is really just 4 plus 4, which is 8. So my limit as x approaches 16 of this function ends up being 8. Here's another one with factoring. This one is asking for what value of k does the limit as x approach 4 of this expression exist? Again, I've got a problem here because if I try plugging a 4 in, I've got 4 minus 4 in the denominator, which is 0. I can't divide by 0. That makes finding this limit tough. So for this limit to exist, I need to not be dividing by 0. Only way that's going to happen is if I've got an x minus 4 somewhere up here to cancel out with that one down there. So the values of k that I would need is I need some value of k so that this would factor, and one of the factors would be x minus 4. There's several ways to do this. Luckily, this one was multiple choice, so I can just look at these and kind of think, all right, which one of these could I plug in to make that factor? I would say probably that minus 12. You can double check if I've got x squared minus x minus 12. Yeah, that's definitely going to factor into x minus 4 and x plus 3. So if that k was the minus 12, I would have an x minus 4 as one of the factors. It would cancel out, and I would be left with that x plus 3. I could then find the limit. I'd plug that 4 in. 4 plus 3 is 7. That's probably why this distractor is here. But the k that I would have to have would be a k value of negative 12. So my answer is A. Moving on, very last section, finding limits by analyzing. Analyzing is just a fancy way of saying thinking. Find the limits by thinking your way through it. This one is asking for the limit as x approaches 0 from the right-hand side. Well, if x is approaching 0, it's getting smaller and smaller and smaller. I can't just plug in a 0 because square root of 0 is 0. And again, I can't divide by 0 and expect an answer. But I can imagine, I can think my way through about what happens as this denominator gets closer and closer to 0. As I take 1 divided by something that's getting closer and closer to 0, the end result is I get a number that's getting bigger and bigger and bigger, like 1 divided by 0.1. That's equal to 10. 1 divided by 0.01. That's equal to 100. 1 divided by 0.001. That's equal to 1,000. The smaller and smaller that denominator gets, the bigger the end result of 1 dividing by that number is. So the limit as x approaches 0 is going to be infinity. This answer is going to get bigger and bigger and bigger. So my final answer, I think I hit it up there. Yep. Final answer is infinity. Now, some of you guys may recall that this is technically a limit that doesn't exist. Limits only exist when they approach a specific number. Infinity is not a number. So yes, you could technically say does not exist. That is technically a correct answer. However, infinity is a more correct answer. It's describing the way in which the limit doesn't exist. Why doesn't the limit exist? Because the limit gets closer and closer to infinity. So that is the answer you should write. Here we've got a few more limits as x approaches infinity. This one, we could think of it in terms of horizontal asymptotes. You might recall that functions like this would have a horizontal asymptote at 0, which means as x goes towards infinity, this function is going to get closer and closer to 0. I find problems like this actually tend to be easier, especially when they get more complicated, to just think about them in terms of as x gets really, really big, and then think of them in terms of overpowering. As x gets really, really, really big, that -7 is going to have almost no impact on x squared, right? If I take 1 billion and put it in there, 1 billion squared is so big, the -7 has hardly any impact. Same thing for the 2x. Hardly anything compared to that x squared once x gets large enough. So as x goes towards infinity, that 2x and that -7 become essentially ignorable. And this limit would be the exact same limit as if I didn't have that 2x or that 7 there. Are they there? Yes, it's just it makes such a small difference that it's ignorable. I could say, hey, I don't really need those ones. It's going to be the same as this limit. This limit I can look at and say, well, that's an x squared on top and x to the 5th on bottom. I can simplify that. I get this limit. And the one last step, I say, hey, x is going towards infinity. That's a really, really, really big number. So as I take 1 and divide it by a really, really, really big number, I end up with a number that's getting closer and closer and closer to 0. Next one down. Same thing here. You could use your idea of horizontal asymptotes. If you remember functions like this, then since the power is bigger on top than on bottom, this does not have a horizontal asymptote. The question is, does that mean the function's going up towards infinity or down towards negative infinity? And I don't know. Actually, I do. But the easiest way is to, again, think of these in terms of overpowering. As x goes towards infinity, x to the 4th is going to become so big it overpowers that -2300 to be almost nothing. It'd be negligible. Same thing with x squared. It's going to become so big that 3x is going to become almost negligible. And this limit would be the exact same as that limit, just looking at the highest powers. X to the 4th divided by x squared, that's just x squared. So this would be the same thing as the limit of x squared as x approaches infinity. As x approaches infinity, x squared is pretty obviously also going to approach infinity. Don't have one of those handy things hidden there here this time, so I'll just write infinity. Very last problem would be the limit as x approaches infinity of sine of x. Well, sine of x just goes up and down and up and down and up and down forever. No matter how far x goes, it's going to keep going up and down. That's not approaching any particular number. So the limit doesn't exist. It's not going up towards infinity either, or down towards negative infinity. It just keeps going up to 1 and then down to -1, and then up to 1 and then down to -1. Since it's not approaching any particular number, the limit does not exist. All right, one final problem. I think I'm setting the time just fine to make my 15-minute limit here. One last one with x going towards infinity. These ones tend to be the ones people struggle with most, so I had the most examples on them. Same thing as before. As x goes towards infinity, x cubed is going to become so big that the 2 is negligible. 5x is going to become so big that the -4 is negligible. This limit would be the same as that. And I can look at this and say, well, cube root of x cubed, I know that, that's just x. Why write it like this? Let's write it as x. And then finally, when I look at this, I can say, hey, well, those x's are going to cancel out. And I'm just going to end up with 1/5. And then as x goes towards infinity, 1/5 is just going to stay at 1/5. It doesn't care what x is doing. No matter how big x gets, 1/5 is always still going to be 1/5. So this limit is equal to 1/5. All right, that was your review on limits. I hope it went well. If you have comments for me to improve, let me know. Email me, robert.anderson@isd623.org. Your assignment is a limits worksheet. It is on Schoology. Give it your best shot. There's an answer key. Check out the answer key. I try to be as detailed as possible on the answer key to help you out. Good luck, and I will talk to you soon. Bye-bye.